My name is Sakas Thapa. In this video, I will explain my network type design recommendation for Sydney and Melbourne sites. I will also show the GRE VPN implementation and explain why certain technologies were chosen to improve performance, security, and reliability. So, talking about my topology overview, I have used one ISP in the middle and two router. One is for Melbourne and one is for Sydney, and I have separated different departments, so VLAN 10 IT and VLAN 20 HR. The network has two locations, Sydney and Melbourne. Melbourne uses VLAN separate department, and VLAN 10 is used for IT department, and VLAN 20 is used for HR department. Sydney hosts internal networks and services. In the previous design, the two sites were connected using RIP version 2 for routing. And now I will explain why RIP was not good enough. Because RIP works for small networks, but it has many limitations. It uses hop count, and its metric has slow convergence. This means if a link goes down, the network takes longer to recover. And RIP also does not scale well, and it is not suitable for enterprise network that may grow in the future. So for this assessment 3, we have chosen uh, OSPF instead of RIP version 2. OSPF helps to solve these issues. I upgraded the routing protocols to OSPF. OSPF is faster, more reliable, and uses cost instead of hop count to choose the best path. It converges very quick, which reduces downtime. OSPF also works very well within the VPN tunnels, which is important for this design. A GRE VPN tunnel was implemented between Sydney and Melbourne. The tunnel uses the network 192.16.100.3, where Sydney uses one IP and Melbourne uses the other. GRE creates a virtual point-to-point link between the two routers. This allows OSPF to run over the tunnel and dynamically exchange routes. During implementation, an issue called recursive routing occurred, which was fixed by using correct static routes. The tunnel MTU was also adjusted to uh, prevent packet fragmentation. So now we are going to show the GRE verification. Um, Now I will verify that GRE tunnel is working. So let me type passcode Cisco enable CLAS plus plus. So interface tunnel 0. So here we can see tunnel 0 is up, line protocol is up. It's mean it's connected and hardware is tunnel. And MTU, we can see here MTU is 17916 bytes. So this means this shows like it's working. And now we will also ping test. So it's both the Sydney and the Melbourne are connected to each other. So let me ping 192.168.100.1. So here we can see success rate is 100%. This means like Sydney and the Melbourne both are connected and working perfectly. Uh, Now I will show you. So IP OSPF NEIGSBOR neighbor. Here neighbor ID is 1.1.1.1 and state is full. So address here interface we can see tunnel 0. This shows that OSPF has formed a full neighbor relationship over the tunnel. Now we will do the end-to-end connectivity. Mm, For this one, let me type on the Sydney router. Cisco enable us. So I will do the ping test on Sydney router 172.3.10.1. So here we can see this confirms that the VLANs in Melbourne can communicate with the network in Sydney using OSPF over GRE. Uh, so let me fix this one here. Mm, mm. Now, now we will be talking about the wireless and monitoring. A secure wireless design was also proposed. Corporate user connect using WAP3 enterprise and are placed into the correct VLANs. Guest user are isolated in a separate VLAN with internet only access for monitoring. PRTG network monitor was recommended because it is easy to use and can monitor GRE tunnels and routing status. So in conclusion, what I want to say is replacing RIP with OSPF and implementing a GRE VPN improved network reliability, security, and scalability. This design chooses follow enterprise best practice and support future network expansion. Thank you for watching.